it will provide some options for TypeScript. According to that, we have to use TypeScript. In that, one of the main concept is in Angular, TypeScript uses type inference primarily. That's the reason in older versions of Angular, when we have to declare any variable, we have to define the data type. But now we don't need to define the data type. Just declare the variable, initialize the value. According to the value initialized, it can be configured to that specific data type. That is what actually the concept of type inference. So you will see that we use this regularly in our Angular. Next important is you need to understand about type compatibility. Type compatibility in TypeScript, actually in TypeScript, type compatibility is based on structural subtyping, actually. Structural subtyping. This is also we learned. Structural subtyping also we learned. What is structural subtyping is nothing but actually structural subtyping is like this. That means usually we define a syntax like this, an interface. iProduct is an interface. And this interface is having name, which is a string type. And we are implementing here. Suppose we have class. Class have a product. Class have product. In that, the name is defined as string. That means both are having the same type. But important, class is not implementing. Class is not implementing the interface. Currently, class is not implementing the interface. Now, suppose if I defined like this, let obj is iProduct, and that means it is of type iProduct. Type is iProduct, and obj is equal to new product. Now tell me, is it valid? That means object is interface type, but it is using the memory of class type. It is using the memory of class type. But important is here the class is having the same type of members of an interface, but it is not implementing. There is no implements. It is not implementing. It is not extending, but it is having the same type of members. It is not implementing. Is it possible to allocate memory of the class type for a specific interface type if it is having same type of members? So that means in TypeScript we have a structural subtyping mechanism. Because of this subtyping mechanism, what happens is, even if you don't define any relationship between them, then what it does is, according to the memory allocated, it will verify whether the type and the memory allocated have the same type of members or not. And if it is having same type of members, that means if it identifies that it is same type of memory, it is the same type of memory, then it allows to handle this situation. Then it allows to handle this situation. Then it will allow to do that. Allow to do that. So this mechanism is called type compatibility. Compatibility. That means it will check the compatibility while allocating the memory, even when they are not defined with relation. That means the above technique is valid. The above technique is valid. TypeScript supports structural subtyping structural subtyping, which identifies the compatibility while allocating memory and assigns value into memory. So this is known as and assigns into memory. So that means it which identifies compatibility while allocating the memory and assigns value into memory, even when the relation is not defined. Even when the relation is not defined. This is known as type compatibility. This is known as type compatibility. So two important things you need to know, which are very regular in interviews: type inference and type compatibility. So if anyone asks, suppose sometimes in interviews, they will give you a syntax and they will ask, what is it? For example, LET, we said employees is an employee type array. And you observed, we already learned. So new developer and a new consultant and a new manager. That means the employee is the base type and all others are derived type. So a base class object is using the memory of derived class objects. Remember, only single relation is defined here. That means all are of type employee. That means this is different type. Second one is different type. This one is also different type. But while allocating memory, it will verify all belongs to the same type or not. Then it will allow. So this already we discussed in the concept of polymorphism. Actually, this is a good example for type compatibility. Because the employee is employee type, but the memory used is not directly employee type. This is of derived types. This is type compatibility. Need not to be having a relationship. Without relation also it can check the compatibility. And it can handle the compatibility. So that is very important, right? So these are the basic things that we have to know while we